Alright, in this video we're going to look specifically at histograms. Now, a histogram looks like a bar graph, but it's very important that we pay attention to the difference between the two. A bar graph is specifically for categorical data, whereas histograms are for quantitative data. So, a bar graph is, or a histogram is kind of like a bar graph, but it's for quantitative data. The vertical axis on a histogram measures how much data is in each bar, which is just like a bar graph would be for categorical data. A frequency histogram, we've already talked about the difference between frequency and relative frequency. A frequency histogram shows the number of data points that are in each bar. A relative frequency histogram shows the percent of data that's in each bar. So again, similar to the other places we've seen those two before. When you're making a histogram, each bar needs to cover the same range of values. And we'll talk a little bit more about like what I mean by that, but the width of your bar, the how many numbers each bar represents needs to be the same size across your whole graph. Generally speaking, somewhere in 5 to 7 bars is a good minimum. If you're drawing your own histogram from scratch, you're going to have to look at how spread out your data is. So like if my data goes from 0 to 20, I might have bars that are only 2 or 3 units wide. If my data goes from 0 to 2,000, then my bars might be like 1 or 2,000 wide. So it just depends on how spread out your data is. And with a histogram, your axes always must be labeled. Your y-axis is either going to probably be frequency or relative frequency, but we also need to label what the x-axis is, like what are your data points. In general, if you're starting to make a histogram, it's a good idea to sort your data and put it in order. And we already talked on the calculator in an earlier video about how to do that sort in ascending order command. And then look at how spread out your data is in order to determine what your class size should be. So we'll look at making one in a minute, but here's a histogram that's already been made. They've labeled frequency on the y-axis. In this case, the actual data points are the course score for something. And we don't have the context, but they're telling us that's what those numbers are. In this case, the width of each bar is 100 units. The first bar goes from 0 to 100. The second bar goes from 100 to 200. The next bar goes from 200 to 300. And they would have to keep each bar the same width all the way throughout. If you also look too, the bars are kind of spread between the numbers. So my tick marks are at 100, at 200, at 300, and then the bar stretches in between them to show, hey, this bar has all sorts of numbers between 100 and 200. And the height of the bar then just tells us how many, in this case, how many people had each of those course scores. To practice making one, we're going to actually look at the same data. This was from a class. We looked at this data before when we were working in an earlier video. We need to be careful in our histogram. We need a consistent scale on both axes. We need labels for both axes. We need a break on the x-axis if not starting at 0. In this case, our scores don't go all the way down to 0. My lowest score is 23. So on my graph, I would show that by just making a couple of tick marks. You can also do kind of like a zigzag, like almost like a light. Oops, that pen doesn't make any sense for this. Almost like a lightning bolt. That kind of shows. The idea is we're showing a break because in a graph in general, when you have the two axes meet, then that should happen at 0. But if I'm skipping a whole bunch of stuff in the x direction and not actually starting my numbers until 20, then I want to show that there's a break in that axis. And then the last thing we need to include is our data. Our y-axis must start at 0. And this actually goes back to some of those tips for categorical graphs. Even though I can show a break and start my x-axis somewhere higher if that's where my numbers are, my y-axis should always go down to 0. I might need to change my scale. If I have a ton of data points, each of these tick marks might represent 50 data points. But I have to start at 0 and then start counting up from there. Now, I already have this marked off over here, but what I did was I looked at my numbers and I said, well, my lowest number is 23, my highest number is 53. So I'm going to be going roughly a spread of 30. If I want to have a decent number of bars, but I want to kind of pick by something that's easy to count by, counting by fives kind of makes some sense. So my first bar is going to be from 20 to 25. My second bar is going to be from 25 to 30, then 30 to 35, all the way on over. If you have a data point that happens to fall right on one of these boundaries, so if I actually have the data point 25, which I do in this set, it's as long as you're consistent, it's actually up to you whether you put 25 with the lower bar or 25 with this higher bar, 25 to 30. I'll say most often people would put it in the higher bar, but as long as you're consistent, you would still get full credit. I need to label. In this case, these were class scores on a quiz, so I'm going to put scores down there. I'm not really going to put my Y. Well, I guess I could look at the total number of data points. There was 28 data points in this set, so it probably makes some sense to count maybe by tens, or sorry, count by ones. And then this is going to be frequency because I'm not converting these to percent. But the idea is you would just sort your data, and then we're really just going to count how many data points are in each range. If I'm looking from 20 to 25, there's only one number in that range. When I get to 25, I just said a minute ago, I'm going to put that in the higher class. So my first bar is only going to go up to 1. From 25 to 30, I have 25, 27, 27, 29. That's 4 numbers. So my next bar should go up to 4. Then from 30 to 35, I've got 31, 32, 33. That's it. So I have 3 numbers between 30 and 35. And then you just keep on going. You can use your calculator. You can also do it on paper. But we're just going to count how many numbers are in each bar, and then make my bars go up to each of those heights. And that's pretty much it for making a frequency histogram. If I wanted to make a relative frequency histogram and go one step further, all I really need to do is count up how many data points there are total, which here it was 28. And I'm really just calculating for each of those, however many there were in that bar, divided by the total number of points. And then however many there are in the bar, divided by the total number of points. And how many there are in the bar, and you're just dividing all the way down. And honestly, the graph looks pretty much the same if you compare that to the last one. The difference is, now over here, it's a percentage. Oh, I forgot to bring my labels over. But that's it. So to be honest, unless they ever forced you to make a relative frequency histogram, which they won't. To be honest, I think it's unlikely you even have to make a histogram, just because they're so time-consuming on the AP test. But if they asked you to make one, I would make just a frequency one and just save that extra step.